Hello everybody and welcome to your video notes on Learning Target 8.5, the basic level. This is going to be a part 1. And the reason why this is going to be a part 1 is because this is the focus for what we're doing here. And what we're trying to do is determine the resistance, current, and voltage of each resistor in both a series and parallel circuit separately. This one we're just doing series circuits. So here's our goal for this video. I want you to be able to fill out a table like this. I'll show you what the table looks like. It's going to be for a series circuit. Okay, I'm going to show you the table now. Okay, so this is what we got. We've got our table right here. This is what your table is going to look like, and we're going to do it for this circuit. But you should be able to do this for any series circuit. And you know this is a series circuit because it's all in a line. So if we just get started here, and I'm going to go ahead and change my color just because we're fancy like that. And the first thing that we can do in any of these problems, and this goes for parallel as well, is R is easy. Fill it in. It's always a place to start. So we've got 55 ohms, 50 ohms, another one that's 55 ohms, and then our last one is 5 ohms. And we're just going to call this 1, 2, 3, 4, and then this will be our totals. Okay, so all that I did is I just took these numbers here and I put them in the table. Okay, that doesn't seem too bad. And then I is the same. It's just the same. And note that this is just in series. I should note that all of this is series. You will have a different set of rules for parallel circuits. The voltage is going to change at each resistor. I should say the voltage changes. And this is because all voltage must be used up. It's kind of like being used up in a loop. All the voltage has to be used up in a loop, so it will change at each one of these resistors. And the reason why the current is the same, if you're curious, is because there's only one path. There's only one path going around this, going from the battery and then going around like this. Current can't change because there's only one path. Okay, and so that's kind of your starting point here. Go in here. I'm going to change the colors again, and I'm going to give you the steps that you need. So step 1. We're going to find our total. So it's easy. Just add them up. So all that I need to do for the R total is just do 55 plus 50 plus 55 plus 5, and we get a grand total of 165 ohms. Pretty easy, right? Okay, so we did that. Check mark. Step 2 is calculate R. calculate I with Ohm's law. Okay, which is I equals V over R. And then the last thing will be find the individual voltage. Okay. So, we know that the total voltage is 12 volts. So then it's going to be easy to find this because we know that I equals V over R. So we know that we've got 12 volts divided by 165 ohms. And so that's going to give us a rounded answer of 0.0727 amps. Okay. Okay. So we found step 2, and now we just have to find the individual voltages. So the way we're going to do that is again with Ohm's law. So if we rearrange that, we end up with V equals I times R. And for 1, we've got V equals I 0.0727 amps. And the reason why I can use this number is because remember that I is the same. So really I can say 0.0727, 0.0727. It's the same for all of them. I can come down here and I'm going to multiply that by the resistance for 1, so that'd be 55 ohms. My answer that I get for that is 3.9985 volts. So then I can come up to my table and write 3.9985 V. Okay. And do the same thing for 2. I'm going to do 0.0727 amps times that voltage, which is 50. Sorry, not that voltage, that current. Not current either, resistance. And I end up with 3.635 volts. And then we'll notice that these two are the same because the resistance is the same. And then the last one is going to be 0.0727 amps times 5 ohms because, again, we've got 5 ohms there. And we end up with an answer of 0.3635 volts. And there we have it. Filled out one of these tables, and that's what we got. So remember, R is easy. We filled that in first. I is the same. You'll notice that the current was the same in all of these. The voltage changes at each resistor. You'll notice that the voltage changed at each of these resistors. And a few other little reminders here. So we got our total by adding everything up. The V total, it's always given. And then the I total, I may have already said this somewhere. The I total is just I. Don't add. Okay? That's what we got. All right, now I want you to try doing this one on your own. I'm going to do the rest off the screen, and then I'll show you my answer when I've completed it. So here you go. Now you try. All right, and here is what I got for my answer. I started just by, let's see, let's pull out a highlighter. Let's do green. So I started by calculating each of these. Well, I didn't have to calculate them. They were just given to me, right? So I just went over here and said, hey, look, 75, 55, 25. Okay. And then to get this answer, I just added them up. That's how I got that. And I went through my steps. I found my R total. I calculate I with Ohm's law. So I was given this as well. That's 15 volts. So I did this right here. So I did I equals V over R. I got 15 volts divided by 55, or 155 volts. And I got this. Okay. Then I brought that up here. And it's the same for all of my currents because I is the same in series. Okay. All that was the same. And so then all I had left to do was find the individual V's using Ohm's law. So 7.26, 7.26, 4.84, 4.84, 0.484, 0.484, 2.42, 2.42. There we go. That's all I got. And thanks for listening.